The described wiring method of using number 10 AWG wire for the first 100 feet to pull box and then continuing with number 12 armored cable to receptacle locations is not code compliant. This scenario directly relates to the tap rule within the National Electrical Code, often abbreviated as NEC. The tap rule is a critical safety measure intended to prevent overloading and potential fire hazards in electrical systems. It dictates the conditions under which a smaller conductor can be connected to a larger conductor without overcurrent protection at the point of the tap. The fundamental principle of the tap rule is that the smaller conductor, the tap conductor, must be adequately protected against overcurrent. If it's not, the smaller conductor could overheat and potentially cause a fire. The specific section of the NEC that addresses tap conductors is Article 240.21. This section outlines the various requirements and exceptions for tap conductors in different situations. One of the core requirements, and the one most relevant to the scenario, is that the tap conductor must not be smaller than the ampacity required for the load it serves. Furthermore, the tap conductor must have an ampacity of not less than 1/3 of the overcurrent device protecting the feeder or branch circuit conductor from which it is tapped. This provision ensures that the tap conductor can safely carry the load it's intended to supply without being overloaded. Another critical aspect of the tap rule is the length limitation. There are specific length requirements for tap conductors, depending on the application and the overcurrent protection provided. The intent of these length limitations is to minimize the risk of voltage drop and ensure that the tap conductor is adequately protected. The 6-foot tap rule, often mentioned in this context, is one specific type of tap rule that allows for short taps under certain conditions. However, even under the 6-foot tap rule, there are strict requirements that must be met. For instance, the tap conductor must be protected from physical damage and must terminate in a single overcurrent device. Now, let's analyze the specific scenario. The initial 100-foot run uses number 10 AWG wire. Number 10 AWG wire has a certain ampacity rating, which is the maximum amount of current it can safely carry. The drawings specify 15 amp branch circuits. While number 12 AWG wire is typically suitable for 15 amp circuits, the problem arises because it is being tapped from a number 10 AWG conductor. According to the general tap rule, the number 12 AWG conductor cannot be smaller than the continuous conductor from which it is tapped, which in this case is the number 10 AWG conductor. Essentially, the code requires that the tap conductor must be at least the same size as the conductor it's tapped from, unless specific exceptions are met. In this case, those exceptions are not met. The 6-foot tap rule is not applicable here. The 6-foot tap rule is designed for very short taps, typically within an electrical enclosure, and it's subject to strict conditions. Firstly, the tap conductor must not exceed 6 feet in length. Secondly, the tap conductor must be protected from physical damage within a conduit or raceway. Thirdly, the tap conductor must have an ampacity of at least 1/10 of the rating of the overcurrent device protecting the larger conductor. And fourthly, the tap conductor must terminate in a single circuit breaker or set of fuses that will limit the load to the ampacity of the tap conductor. These conditions clearly indicate that the scenario with a 100-foot run of number 10 AWG and then a transition to number 12 AWG does not fall under the 6-foot tap rule. The length of the number 12 AWG run far exceeds the 6-foot limit, and the other conditions are also not met. The number 12 AWG conductor does not have an ampacity of at least 1/10 of the overcurrent device protecting the number 10 AWG conductor. Therefore, the proposed wiring method is a violation of the NEC tap rules. It is essential to maintain conductor sizing consistency or provide appropriate overcurrent protection at the tap point to ensure safety and code compliance. The solution is to either continue using number 10 AWG wire throughout the entire run to the receptacle locations or to install overcurrent protection at the point where the number 12 AWG conductors are tapped from the number 10 AWG conductors. The overcurrent protection should be sized appropriately for the number 12 AWG conductors. Another option is to use number 12 AWG wire for the entire run, provided that the circuit is properly protected with a 15 amp circuit breaker. However, this would mean that the initial specification in the spec book which requires a minimum of number 10 AWG for runs over 100 feet, is not met. Therefore, it's crucial to understand the NEC tap rules and apply them correctly in electrical installations to ensure safety, prevent overloads, and minimize the risk of fire hazards. In summary, the proposed wiring method is not code compliant because it violates the tap rule. The number 12 AWG tap conductors must be at least number 10 AWG, or appropriate overcurrent protection must be provided at the tap point.